Speaking of Israelis, I was reading this UBS investment research report on Intel and a couple of interesting things. One of the things that UBS says is that here on talking about Intel, saying execution strategies. So AMD is supporting their x86 development both out of Haifa, Israel, and Hillsboro, Oregon. So, right now Sun's very focused on Opteron technology for our currently shipping products, but this, again, publicly listed UBS document here says, later in 2008, we expect Intel to move to its next generation architecture, closely resembling AMD systems with an on-chip memory controller and chip-to-chip communications interface called CSI. So when I think of CSI, I just think of the TV show, but obviously Intel has got something different. What do we know about CSI, that sort of public information, and is that going to be an interesting technology?
Yes, definitely. So CSI, so it's the final bottleneck that Intel has with their bus-based technologies will finally go away with this CSI technology. This is common system interface that essentially is equivalent to hypertransport in the AMD world. It should provide the similarly scalable bandwidth both intranode, in other words, bandwidth between the sockets, as well as bandwidth and low latency communications from node to the outside world through the CSI.
So it says, this is UBS speaking again, we also expect Intel to launch its first 8-core chip in 2008 called Gainestown. So I guess they will really need CSI to get that performance out of Gainestown. So Sun has, of course, our own 8-core chip, the Niagara processor, which is shipping today. And we publicly talked about the follow-on of that, Niagara 2. I mean, what do you think about Niagara 2 in the HPC space? Is that going to be an interesting chip?
Yeah, so it could be quite interesting, especially with the Niagara 2. Some of the improvements that you may already, the Niagara 2 is, there's a lot of good public information already out there with respect to the number of floating point units and so on. So as you remember, in Niagara 1, there is only one floating point unit for all the cores. So all the cores share the floating point unit. On the other hand, Niagara 2 has a single floating point unit per core. So it could be actually quite interesting, even though it is not a quad flops per cycle. Then again, very few cores can actually achieve quad flops per cycle. It seldom ever happens that one can line up the computations in realistic scenarios from real applications. So even though theoretical performance of Niagara 2 may not match to the typical AMD Intel processors, the sustained performance, especially the performance per watt, you should see some interesting results from that. And
well, my spies in Sun Engineering tell me that we'll be getting the first sort of customer early access units of Niagara 2 very soon. So hopefully we can get some real customer codes running on that.